All right, so complex fractions number 3. Again, make sure that you've got paper, loose leaf. Make sure you take notes. This is definitely going to help you when you go to do your Castle Learning assignment. All right, so let's look at the first one. We understand that, again, this is definitely a complex fraction. We've got fractions in the numerator divided by, well, this isn't necessarily a fraction, but we know that we can just put that over 1, and now we got a fraction. All right, well, while we're at it, let's put the 4 over 1. And like in the last video, we need to find a common denominator for 1 and x. So I am going to choose x. So if I multiply this denominator by x, and what I do to the bottom, I have to do to the top. And then you can see here that I now have a common denominator of x. All right, so why don't we just rewrite this fraction again off to the side. I have 4x minus 16 over x, and then that whole thing is over x minus 4 over 1. All right, so this is the way we like to have our complex fractions set up, remember? So we have one fraction in the numerator, we have one fraction in the denominator. Once we do that, we can keep, change, flip. So let's get to it. We are going to keep the first fraction, so that's going to be 4x minus 16 over x, change to multiplication, and flip that second fraction. Now let's take a look at what we have here. Why don't we make that look like a 6? There we go. All right, so if we look at this, well, we have nothing to cancel here, we have nothing to cancel here, we have nothing to cancel here, because remember, this is a binomial and this is a monomial, so we can't cancel these x's. However, let's look this way. Now, at first glance, they do not look the same, but notice that these guys have a factor of 4. So how about we try factoring this out a little bit and see if maybe that helps us. I'm going to take out a 4, and when I do that, I'm left with x minus 4. I'm going to keep the denominator, keep the multiplication sign, keep the second fraction. So all I did was I factored out that numerator in the top left-hand side. Now, by doing that, look at what I had. I had a hidden binomial that matched this one that I didn't know that I had if I hadn't factored it. So that cancels and that cancels. Now remember, when we're multiplying fractions, we multiply left to right. Numerators with numerators, denominators with denominators. So our final answer is going to be 4 over x. Number 2. Again, make sure you're taking notes on this. So we need to find ourselves a common denominator, and actually on both of those guys, right? So I have a 7 monomial and I have an x monomial. Let's just smush those together, and that's going to be 7x. So I'm going to multiply by x here, and then over here I'm going to multiply by 7. And you see that when I do that, that gives me that nice common denominator right here of 7x. Okay, now down here, remember, this really isn't a fraction, but we can make that a fraction just by putting it over 1. All right, so now we have an x and we have a 1. We are going to make that common denominator just an x. So let's multiply the denominator by x, and let's multiply the numerator by x. And off to the right side, I'm just going to rewrite everything, maybe looking a little bit prettier than what I've got right now. Okay, so in the top part, or the numerator of my fraction here, I see that I have a common denominator of 7x, and then up here I have x minus 7. All right, so let me write that. So x minus 7 over 7x. And then let's look at the denominator here. I have 7 minus x over x. 7 minus x over x. All right, well, now we're at that point where we have one fraction divided by another fraction. We can keep change flip. All right, so I'm going to keep the first fraction. I'm going to change that division to multiplication, and I'm going to flip the second fraction. All right. Let's look at what we've got left and see if we can simplify anything. See if we can cancel any numerator with any denominator. Well, I see right here I've got an x and I have a 7, and these are both monomials. I'm sorry, an x and a 7x. Remember though, when I'm canceling that, I'm just canceling the x and not the 7, so the 7 remains. Now, let's see who remembers this from somewhere in the middle of the school year. X minus 7 and 7 minus x. What do we know about these two guys? Do you see these are opposites of each other? This is a negative 7. This is a positive 7. This is a positive x. This is a negative x. So this monomial is the complete opposite of that monomial. And you know, I've been saying to you that 2 plus 3 is the same as 3 plus 2, right? When you have addition, if you flip-flop the numbers, it's the same. But when you have subtraction, it's not. So what I mean by that is, think about 3 minus 2. That's 1. But 2 minus 3 is negative 1. So when we subtract, it's not commutative. It's not the same number. So do you remember that what we can actually do is we can cross these guys out, but remember we have to just multiply by a negative 1, and we can multiply by a negative 1 either in the numerator or the denominator. It really does not matter. I tend to, and what I have done with my kids this year is I've just said that I just tend to always throw it in the numerator. Okay, all right, now let's look and see what we have left here. So in the numerator then, if I have the negative 1, if you put it up here, that's fine. If you didn't, I'll talk about that in a minute. But everything else canceled out. So then in the numerator in our answer, I'm going to have negative 1. Now let's look at the denominator. In the denominator, I have 7, really times 1. Now if you had taken this negative 1 and put it down here, you in the denominator down here would have a negative 7. Okay? But think about it, it really doesn't matter. This is the answer, but I could have, if I wanted to, I could have written it like this also. That's also the same. So wherever you want to put that negative, it doesn't matter. But just remember that subtraction is not commutative. So when these guys are opposites of each other, we can cancel them out as long as we multiply by a negative 1. Okay, well, we've got 2 fractions in the numerator and 2 fractions in the denominator. So you know that we need to find a common denominator. I am going to start by putting this over 1. So you tell me, what's that common denominator going to be up here? What's that common denominator going to be? What am I going to have to multiply this first fraction by? How about that? And I hope you are saying that you're going to multiply it by x. Top and bottom, right? All right, now let's look at the denominator, this bottom here. You've got an x squared monomial and an x. What's the common denominator there? And I hope that you are saying x squared, because if I say x squared, I can just leave this alone. And then watch. If I just multiply this by x, there's that x squared. So x squared here, x squared here. Okay? All right, so let's move everything off to the right over here and let's simplify. Let's look at the top part. So the top part, remember, the common denominator is x. What will be the numerator? It's going to be x minus 1, right? All right, Now, let's look at this denominator. So this denominator here is x squared. And let's figure out what we're going to put in the numerator of that. So let me write this. So I've got x squared down here. What goes in the numerator? 1 minus x. Okay, now, can we keep change flip? Yes, because we have one fraction divided by another fraction. So now it's good to go. We can keep change flip. We're going to keep the first one. We are going to change to multiplication. And we are going to flip that second fraction. All right. Now, I notice here that I have a common factor of x. I am going to cancel that out then. So this will just leave me with a 1. And here, if I cancel an x out, I still have one more x left, don't I? All right, now let's be really careful. We just spoke about this in number 2. What do you notice? Do you see that these guys are opposites of each other? So just like in number 2, what is it that we have to do to cancel these guys out? Multiply by a -1. Where do you put the -1? It doesn't matter. Either in the numerator or the denominator. Not in both places, but either one. Miss Carter likes it in the numerator. I don't know why. I just do. All right, and lastly, let's just multiply across when we multiply fractions. So I have -1 times x, and that is going to give me -x. And then in the denominator, let's see what I have left in the denominator. Oh, I have nothing left in the denominator, which really means what do I have left in the denominator? A 1. Now, do I need to write my answer like that? No, that looks weird to me, so I'm just going to write -x. But if you wrote it like that, by the way, it's totally fine. All right, last question. So let's take all these fractions and let's put, or actually all the whole numbers, and let's put 1s as their denominator. And how about we tackle right up here first? What's the common denominator going to be? I hope you're saying x. So the first fraction has to get multiplied numerator and denominator by x. All right, now this one has 3 fractions. 1, 2, 3. Monomial x squared, x, and a 1. Okay, what could be the common denominator for all 3? X squared. So what would this first fraction need to get multiplied by? It's right here. What am I going to multiply this by to get this to say x squared? And hopefully you are saying x squared, because 1 times x squared is x squared. And then what are we going to have to multiply the middle fraction by to get it to say x squared? And that would be an x, both in the numerator and the denominator. Now, do we need to multiply this by anything? No, it already says x squared. So we have x squared, x squared, x squared. Alrighty, so let's move on to the right and let's just make that look a little bit prettier. So here's the big fraction line. And what is the denominator? So look over here. What's going right here? X. And then in the numerator, you should have x minus 4. All right, now let's look in the denominator here, this whole big huge mess. So we want to simplify that, make that look prettier. What's the denominator here going to be? And hopefully you are saying x squared. All right, let's figure out what's going to go in the numerator. So we should have x squared minus 2x minus 8. Okay, let's check it out. Can we keep change flip at this point? Yes or no? Yes, we can, because we have one fraction in the numerator and we have one fraction in the denominator. So we can totally keep change flip. All right, so I'm going to keep my first fraction just as is, x minus 4 over x, change to multiplication, and then I'm going to flip that second fraction. So I have x squared, and then I have x squared minus 2x minus 8. All right, now a couple things I want to make you aware of here. Obviously, we're trying to cancel any like terms in the numerator and the denominator to simplify things, see if they have common factors. I want to show you a common mistake that kids make. They think that this x squared and this x squared are the same thing and then they cancel it out. And then Miss Carter and Miss Paris have heart attacks. You cannot do that. This x squared is joined together forever and ever to this trinomial. It's part of that trinomial. This is a monomial. It's all by itself. This guy is a package deal. It's all or none. So never cancel these guys. However, I do see that I have an x and I have an x squared. That's got a common factor. So that has a common factor of x. So that would turn that into technically a 1, and this will become an x. All right, now let's look at this though, because, what does that remind you of? Do you remember? It's a trinomial. What adds to -2 and multiplies to 8. And I'm going to be lazy here. I'm going to write it under here. I'm sorry. I should do it in another step, but I'm not going to. So x in the first part of each parentheses. Now what multiplies to 8? Well, I would say 4 and 2, right? But I need to add to get a -2. So -4 and a +2, right? So what I just did was I just really replaced this with this, okay? And now do you see I have a common factor of x minus 4 with this x minus 4. So we can cancel those babies right out. Boom, boom. All right, and let's multiply across. Well, the only thing we have left in the numerator is that x. And let's see what we have left in the denominator. 1 times x plus 2. All right, so let's write it all down, see what we get. So we have in the numerator an x, and in the denominator an x plus 2. And there is our answer. Now, I want to just draw your attention to one more thing. You remember how I said that you couldn't cancel this x squared here with this x squared here? Because this x squared was attached to the rest of the trinomial. The same thing happens here. I have a lot of kids sometimes will cancel these two guys. You cannot do that. This is a monomial, and this is part of a binomial. Whenever it's attached to something by addition or subtraction, these guys are a package deal. They stay together. They're like peanut butter and jelly. You don't want to split them apart. So this is your final answer.